decoded the motor intention.
The device, called a neuroprosthetic interface, was developed by an international team at the Federal Polytechnic School of Lausanne.
We developed a brain-spinal interface that decodes motor intention from brain signal, bypasses the lesion, sending this information to the spinal cord below the injury in order to reproduce the intended walking movement.
The interface consists of an electrode inserted in the brain cortex that controls the leg and sends signals from its neurons to a computer that decodes the monkey's intended movement.
The computer sends then this information to an implantable stimulator that had the capacity to deliver stimulation at the correct location with the correct timing in order to reproduce the intended extension and flexion movement of the leg.
In the two test cases, the monkey's motor cortex and spinal lumbar regions were still functioning. The device enabled the primates to move their paralyzed legs, raising high hopes that it may work in humans.
For the first time, I can imagine a patient completely pelagic being able to obey to his brain commands through this brain-spinal interface.
Implantable technology that decodes brain signals has previously allowed a human patient to move a prosthetic or robotic hand, but not a complex leg muscle.
This is the first time that a neurotechnology restores locomotion in primates, but there are many challenges ahead. It may take several years before this intervention can become a therapy for humans.
A clinical study is now underway in Switzerland to determine if the implant can help humans with spinal cord injury. Zlatica Hoke, VOA News, Washington.